flange is an external or internal ridge, or rim, for strength, as the flange of an iron beam such as an I-beam or a T-beam. Or for attachment to another object, as the flange on the end of a pipe, steam cylinder, etc., or on the lens mount of a camera. Or for a flange of a rail car or tram wheel. Thus flanged wheels are wheels with the flange on one side to keep the wheels from running off the rails. The term flange is also used for a kind of tool used to form flanges. Pipes with flanges can be assembled and disassembled easily. Some of the materials used to manufacture flanges are cast iron, carbon steel, 12 Mo steel, AL steel and 13 Co 1/2 Mo. Plumbing or piping. A flange can also be a plate or ring to form a rim at the end of a pipe when fastened to the pipe. A blind flange is a plate for covering or closing the end of a pipe. A flange joint is a connection of pipes, where the connecting pieces have flanges by which the parts are bolted together. Although the word flange generally refers to the actual raised rim or lip of a fitting, many flanged plumbing fittings are themselves known as flanges. Common flanges used in plumbing are the Surrey flange or Dansey flange, York flange, Sussex flange and Essex flange. Surrey and York flanges fit to the top of the hot water tank, allowing all the water to be taken without disturbance to the tank. They are often used to ensure an even flow of water to showers. An Essex flange requires a hole to be drilled in the side of the tank. There is also a Warwick's flange, which is the same as a York flange, but the shower output is on the top of the flange and the vent on the side. The York and Warwick's flange have female adapters so that they fit onto a male tank, whereas the Surrey flange connects to a female tank. A closet flange provides the mount for a toilet. Pipe flanges. There are many different flange standards to be found worldwide. To allow easy functionality and interchangeability, these are designed to have standardized dimensions. Common world standards include ASISM, PN-DIN, BS10, and JISKS. In most cases these are not interchangeable. Further, many of the flanges in each standard are divided into pressure classes, allowing flanges to be capable of taking different pressure ratings. Again, these are not generally interchangeable. These pressure classes also have differing pressure and temperature ratings for different materials. Unique pressure classes for piping can also be developed for a process plant or power generating station. These may be specific to the corporation, engineering procurement and construction contractor, or the process plant owner. The ANSI-ASME pressure classes for flat face flanges are 125 and 250. The classes for ring joint, tongue and groove, and raised face flanges are 150, 300, 600, 900, 1500, and 2500. The flange faces are also made to standardized dimensions and are typically flat face, raised face, tongue and groove, or ring joint styles, although other obscure styles are possible. Flange designs are available as weld neck, slip-on, lap joint, socket weld, threaded, and also blind. ASME standards. Pipe flanges that are made to standards called out by ASME B16.5 or ASME B16.47 are typically made from forged materials and have machined surfaces. B16.5 refers to nominal pipe sizes from a 1/2 to 24. B16.47 covers NPSs from 26 inches to 60. Each specification further delineates flanges into pressure classes, 150, 300, 400, 600, 900, 1500 and 2500 for B16.5, and B16.47 delineates its flanges into pressure classes 75, 150, 300, 400, 600, 900. However, these classes do not correspond to maximum pressures in SI. Instead, the maximum pressure depends on the material of the flange and the temperature. For example, the maximum pressure for a Class 150 flange is 285 psi, and for a Class 300 flange it is 740 psi. The gasket type and bolt type are generally specified by the standard, S. However, sometimes the standards refer to the ASME boiler and pressure vessel code for details. These flanges are recognized by ASME pipe codes such as ASME B31.1 power piping, and ASME B31.3 process piping. Materials for flanges are usually under ASME designation, SA105, SA266, or SA182. In addition, there are many industry standard flanges that in some circumstance may be used on ASME work. Other countries, flanges in other countries also are manufactured according to the standards for materials, pressure ratings, etc. Such standards include DIN, BS, and/or ISO standards. Japanese JIS, compact flanges, traditional flanges such as ANSI, DIN and BS all rely on a dynamic joint which, when bending forces and tensile loads are applied, become loose and weak. The gap created by the raised face introduces corrosion problems particularly to the bolting aspect, which is a particular issue in critical environments as the design actually depends on the large bolt forces to maintain gasket integrity. As flange size and pressure requirement increase, the bolting requirement becomes increasingly heavy and complex, resulting in high procurement, installation and maintenance costs. Large flange diameters in particular are difficult to work with, and inevitably require more space and have a more challenging handling and installation procedure, particularly on remote installations such as oil rigs. The principal design of the flange face includes two independent seals. The first seal is created by application of seal seating stress at the flange heel. Heel contact will be maintained for pressure values up to 1/8 times the flange rating at room temperature. The flange also remains in contact along its outer circumference of the flange faces for all allowable load levels. The main seal is the 9-seal ring. The seal ring force is provided by the elastic stored energy in the stressed seal ring. Any heel leakage will give internal pressure acting on the seal ring inside, intensifying the sealing action. The design aims at preventing exposure to oxygen and other corrosive agents. Thus, this prevents corrosion of the flange faces, the stress length of the bolts and the seal ring. Applications of compact flanges. The initial cost of the higher performance compact flange is inevitably higher than a regular flange due to the closer tolerances and significantly more sophisticated design. Subsequently, the product tends to be used in environments where the cost of maintenance or the consequences of leaks are particularly undesirable. By way of example, compact flanges are often used in oil and gas subsea or riser applications, cold work and cryogenic applications, gas injection applications, high-temperature applications, and nuclear applications. Patents and standards. The compact flange was originally a patented design. However, the holder of this patent, Patent No. N0177160, has accepted free use of the flange configurations within the common flange pressure temperature ratings which have been comprehensively described by NASOC, in standard NASOC L005. However, some elements of this NASOC standard may be the subject of patent rights. Queries about patent rights may be directed to Standards Norway. This NASOC standard is based on common principles utilized by VERAX1, Vector International VERAX, SPO, CFS, GC and EVIA, which are all trade names of the manufacturers VERAX. HTTP, www.verax.a, Vector International AS. HTTP, www.vectec.com Offen Galpati http, www.galpati.com Evenaut Limited http, www.evenaut.co.uk, Vacuum flanges. A vacuum flange is a flange at the end of a tube used to connect vacuum chambers, tubing and vacuum pumps to each other. Microwave. In microwave telecommunications, a flange is a type of cable joint which allows different types of waveguide to connect. Several different microwave RF flange types exist, such as CAR, CBR, OPC, PAR, PBJ, PBR, PDR, UAR, UBR, UDR, ICP and UPX. Ski boots. Ski boots use flanges at the toe or heel to connect to the binding of the ski. The size and shape for flanges on alpine skiing boots is standardized in ISO 5355. Traditional telemark and cross-country boots use the 75 mm Nordic norm, but the toe flange is informally known as the duckbill. New cross-country bindings eliminate the flange entirely and use a steel bar embedded within the sole instead. See also, casing head, closet flange, vitalic, references. Further reading, ASME-B 16.5 standard pipe flanges up to and including 24 inches nominal, ASME-B 16.47 standard pipe flanges above 24 inches, ASME Section 2, Parter, Ferrous Material Specifications, Naya, Mohinder. Piping Handbook, 7th edition. New York, McGraw-Hill. ISBN A0-07-047106-1A.